Hello everyone. So in this demo, I'll walk through my full text search application built using Flask and Elasticsearch. So I'll start with the terminal, and for terminal, I'll open up. This is my project structure. It contains .environment file, app.py, static, templates, and dummy data as data.json. So first we'll set up our virtual environment, which is already set. I have used the command .venv/bin/activate to set up my virtual environment. Here we'll use our Python environment and run the codes. Then we'll start with the Docker, and for the Docker, one second. Okay, so for the Docker, we'll use uh, Docker Docker start es-dev. So this is our Docker which is running, and on the share, we'll start with our. Okay, so I'll brief about this project. So this purpose of this project is to reproduce like the full text search speed from the pipeline from the official Elasticsearch tutorials, which is provided in our lecture, including creating text in index creation and data injection, like loading a dummy or data. And so since I've set up already the Python virtual environment and Flask is already set up, we have already env file to load Elasticsearch connection variables. Okay, and for the next step, we have set up our Elasticsearch using Docker as a single node cluster. Since we are not using a single cluster node, so we don't have to specify our API key or anything in our code. I'm using right now for the Docker, and the Docker it doesn't need, it just only needs a name. So I can verify it's running by visiting localhost into my browser. Oh, I'll visit a localhost, and it would be http /localhost 9200. This is my browser. As you can see, we have fetched the JSON data, which is which specify uh, backend is completely running. Like our script is correct, what I have built. So yes, well, okay. Now start with operation. So for the UI, we'll hold it for the later part. So first, for the UI, like I'll start Flask later on to show the facets. So right now, I'll go ahead by just give me one sec. Python 3. So I'll use this command to insert the data. Okay, so Python C, we are in the command. This is the command. And as you can see, index is created and indexing is also completed, and we have indexed like 6 elements in it. So inside this project, like for this, then I'll start with walk through the code. So the code goes in. I'll start cursor, command space, cursor. It's taking some time. Editor, yeah. So this is open now. So first I'll walk you through my search.py code. Yes, search.py. Yeah, so here I have like search.py file with me. So basically in the project, I implemented all Elasticsearch operation in a file called like search.py. So the search.py is responsible for the search service, which create index, which loads data and do other other Elasticsearch operation related to it. So basically, this class connects to Elasticsearch and includes methods to create an index, define field mapping for the title. So this diff init, it sets up the connection It's an object data and and we see if like object data is assigned with the cloud ID, API key, or the Elastic URL. Since we are using only the Elastic URLs, we don't need the cloud ID or the API key. This function ping, it checks, it connects with the what do you say, the Docker Elasticsearch, and it's check if it's still connected or not. So this code, this creates an index, and here we have initially we have started with mapping, and we have uh, introduced like what kind of structure is gonna be dealt with. This line exists equals to check if if the client exists or if the connection is still there. If it exists, it deletes the existing index as it's mentioned here, and it if not exists, then it's create the new one. Next function we have def insert documents. This def insert documents return none type, and it's this helper function insert documents help me to help me in inserting a documents into the and documents into the Elasticsearch Docker. Then we have the next function reindexing. So if in case we have a crash down with the data sets, we have redefined a function reindexing. So every time we don't have to rerun the command boilerplate commands and the commands on the terminal, we can the code itself take care of the responsibility of reindexing if there is a case of insertion of the data again. Next come the main important, and this is the search field, which is a bar which I'll show you into the UI bar. So this search field, it it's the core and heart of the search service we have. So it checks if there is a query. So if since in Elasticsearch the the API call has the JSON data associated with it, so we check if the query is there we add multi-match, we add a further chain of queries to fetch the correct data. Must clause and filter clause. Must clause is used for basically for query, and I've used it for query. And filter clause, I've used it for the extra filters that need to be done to refine the data. So this is the same step I have told. If the filter clause dot append term category, and this is Billy for the fetching. So this was my search.py. So next I have app.py file. And the app.file, I build the Flask web application. The home root accepts user info through query parameters over here. And for text search, category, year, page, size. So size is basically we have like how many data sets have should be visible on a current page. And this is the from is the pagination. It's how many pages needs like how many pages of data needs to be fetched from the database, and that will be displayed to the user. Next, I would like to show the index.html. It's a simple basic HTML page which acts as a user interface, and it contains a search bar, drop-down filters for category and year, a main result section, pagination control, and a sidebar showing dynamic facets. Faceted search is powered by electric search aggregation. As a faceted search, which returns category counts and year counts, allow user to click on facet links to filter results instantly. I'll come to this part when I'll show you when I'll run the Flask, and I'll come up with the facets we have. This is a code walkthrough index.html. Now we'll start with running our Flask app. So in terminal, I'll write, I'll take command space terminal, and I'll run not this one, command n. Okay, okay, we'll run here Flask. We'll command W. We are done. Command tab. So command tab. Go to the terminal here again. We write Flask dash dash app app. So now we have our Flask running at the port HTTP 27 and 5000 localhost 27. I'll copy this and I'll paste it over here, and here it goes. Since we can see other UI we have, and next the so now so since we have the UI working right now, I'll demonstrate the application. So when I open the browser at localhost 5000, I see the clean search interface. And if I search for Flask, let's suppose Flask, the system receives matching documents based on the full text relevance across the title and the description fields what we have said. Since here we don't have set any all categories or all years, so it's basically the search part which is goes here, search.py. Yeah. It doesn't have any like any we say for the filter clause we doesn't have any all categories or all years set here, so it just comes with the query. Query comes and we check with that fields what we have like title and description. So this is how the normal one works with only the search bar. Like I can also for the next feature I can also show you guys the next filter. I see the for example, I can also filter by category. For example, I'll remove this Flask and I'll search tutorial and I'll search the documents. We see that we have learning Flask, Python basics, developing Flash apps on Docker, and tutorial 3. We have three documents, 22 related to 2022. We have 1, 1, 2024 1. In the backend, we are finding this data and we are aggregation it for the UI. Now I can see I'll show you for the year as well. Okay, I set it to the all categories, and for the specific year we can get the data. Now I'll suppose I'll say to 2023 we had for the 2023 all categories, all the data we have is advanced electric search guide. And for the uh, good part is we have for the millions and the for the big data set we have from and size, so that we can set according how many and how much documents the user needs for the correct. Another feature I would like to say, the sidebar also displays the live facets. Uh, for an example, if I remove all this filter and I search, we can see tutorial 3, guide 2 documents, article 1. And if we filter by year, we have documents dated in 2022 is 2, 3, and 4 accordingly. So I can, if I say, let's say Flash, we see search and category. We have page one of one. As we can move to the one, but since we don't have the bigger data set, we I have also set the code for the pagination, which contains previous and the next buttons. To summarize, this project integrates Flask and with Elasticsearch to build a complete full text search system, including index creation, multi-field searching, pagination, filters, and faceted navigation. All requirements from the Elastic tutorials have been like implemented successfully. Thank you. This was the demo, and this is from my end.